Good morning, student. Today we discuss one more new example. So, example is consider the equation. Consider the equation y dash plus cos x y is equal to e raised to minus sin x. So, first condition, find the solution. Find the solution phi which satisfy phi of pi is equal to pi. And second, b, show that any solution phi has property that phi of pi k minus phi of 0 is equal to pi k, where k is any integer. So example is, consider the equation, this given equation y dash plus cos x y is equal to e raised to minus sin x, and first condition is find the solution phi that satisfies phi of pi is equal to pi. And next, show that any solution phi has property that phi of pi k minus phi of 0 is equal to pi k, and k is the any integer. So solution, first we have to calculate phi which satisfy this condition. So given equation is y dash plus cos x y is equal to e raised to minus sin x. Compare this equation with standard form, then we get a of x is equal to cos x and b of x is equal to e raised to minus sin x. Then let a be the function such that a dash is equal to a. Then integrating both sides, we get a is equal to integration a of x dx. Then integration a of x is cos x into dx which is equal to integration of cos x is sin x. Then now in next step, phi of x is solution of given equation. Then we know that e raised to a of x into phi of x derivative is equal to e raised to a of x into b of x. Then integrating both sides, we get here integration and derivative get cancelled. So here put the value of a raised to x and b of x. So e raised to a of x is sin x. So sin x into phi of x derivative is equal to e raised to sin x into b of x is e raised to minus sin x here, which is equal to e raised to sin x into phi of x derivative is equal to e raised to sin x into e raised to minus sin x, that is e raised to sin x minus sin x, which is equal to e raised to 0. E raised to 0 is 1. Then in next step, integrating both sides, we get integrating both the side, we get e raised to sin x into phi of x is equal to integration of 1 dx plus c, constant of integration, which is equal to integration of 1 dx is x plus c. e raised to sin x into phi of x. Then divide both side by e raised to sin x. So we get phi of x is equal to x upon e raised to sin x plus c upon e raised to sin x, which is equal to x into e raised to minus sin x plus c into e raised to sin x. Then now given condition is phi of pi is equal to pi. Then put x is equal to pi. Then phi of pi is equal to pi e raised to minus sin pi plus c e raised to sin pi, which is equal to pi into, we know that sin pi is 0, so e raised to 0 plus c e raised to sin pi is 0, which is equal to pi e raised to 0 is 1 plus c e raised to 0 is 1. Then phi of pi is equal to pi plus c. Then phi of pi is equal to pi, so pi is equal to pi plus c, which is equal to c is, therefore c is equal to 0. Then put this value in this equation, so we get phi of x is equal to x e raised to minus sin x plus 0 into e raised to sin x. Then phi of x is equal to x into e raised to minus x into e raised to minus sin x. Then next condition B, show that any solution phi has property that phi of pi k minus pi of 0 is equal to pi k. Then B first condition is that phi of pi k minus phi of 0 is equal to pi k. That is, we have to calculate phi of pi k minus phi of 0 is equal to pi k. So first of all we have to calculate phi of pi k. Then put x is equal to pi k. We get pi k x. We know that phi of x is equal to x into e raised to minus sin x. Then put the value of x in this equation. So phi of pi k is equal to pi k e raised to minus sin pi k, which is equal to pi k into e raised to, we know that sin pi is 0, so e raised to 0, which is equal to pi k. E raised to 0 is 1. Then phi of pi k is equal to pi k. And in next step we have to calculate phi of 0, which is equal to, put this value in equation, phi of x is equal to x into e raised to minus sin x. So 0 into e raised to minus sin 0, which is equal to 0. Phi of 0 is 0. Then phi of pi k minus phi of 0 is equal to pi k minus 0, which is equal to pi k. Now next example is consider the equation x square y dash plus 2xy is equal to 1 on 0 less than x less than infinity. First condition, show that every solution tends to 0 as x tends to infinity. And second, find solution phi which satisfies phi of 2 is equal to 2 phi of 1. Solution, first of all, given equation is x square y dash plus 2xy is equal to 1. Then divide this equation by x square. We get y dash plus 2xy upon x square, which is equal to 1 by x square. Then which implies y dash plus 2y by x is equal to 1 by x square. Then compare this equation with standard form, that is y dash 2xy is equal to 1 by x square. Compare this equation with standard form, which is y dash plus a of x y is equal to b of x. Then a of x is equal to 2 by x and b of x is equal to 1 by x square. Let a be the function such that a of x is equal to integration a of x dx, which is equal to integration a of x is 2 by x dx, which is equal to, take 2 outside the integration, and integration of 1 by x is log x. Then a of x is equal to 2 into log x. Then now we know that phi is a solution of given equation. Then we know that e raised to a of x into phi of x derivative is equal to e raised to a of x into b of x. Then put the value of a of x and b of x. Then e raised to a of x is 2 log x into phi of x derivative is equal to e raised to 2 log x into b of x is 1 by x square, which is also equal to e raised to log x square into 1 by x square. Then integrating both the side, we get, here also e raised to log x square into phi of x derivative, so which is equal to e raised to, we know that here exponential and logarithmic are inverse functions, so they can cancel each other, so which is equal to x square into phi of x derivative is equal to x square into 1 by x square, which is equal to 1. X square and x square get cancelled, so x square into phi of x dash is equal to 1. Integrating both the side, we get x square into phi of x is equal to integration of 1 plus c dx. Integration of 1 is x plus c x square into phi of x. Divide both side by x square, so phi of x is equal to 1 by x plus c by x square. Then from given condition, we have to show that every solution tends to 0 as x tends to 0. So now taking limit as x tends to infinity, we get limit x tends to infinity phi of x is equal to limit x tends to infinity 1 by x plus c by x square. So here x tends to infinity, then 1 by infinity tends to 0, which is equal to 0. Therefore every solution tends to 0 as x tends to infinity. Now second condition is find solution phi which satisfies phi of 2 is equal to 2 phi 1 phi of 1, so b is equal to b. Now put x is equal to 2 in given equation, that is equation number 1. So therefore now put x is equal to 2 in this equation number 1. So phi of 2 is equal to 1 by 2 plus c x square, that is 2 square is 4, and phi of 1, put 1 is equation number 1, which is equal to 1 plus c, and 2 phi 1 multiply this equation by 2, so 2 phi of 1 is equal to 2 plus 2c. Then as from given condition phi of 2 is equal to 2 phi 1, so phi of 2 is 1 by 2 plus c by 4, which is equal to 2 plus 2c. Interchanging the term, so we get 1 by 2 minus 2, which is equal to 2c minus c by 4. Then 1 minus 4 by 2, which is equal to 4 to ja 8c minus c by 4, which is equal to minus 3 by 2, which is equal to 8c minus 1, that is 7c by 4. Then which is equal to c is equal to minus 3 by 2 into 4 by 7. 2 1 ja 2 2 ja 4, which is equal to 3 2 ja 6, that is minus 6 by 7. Therefore c is equal to minus 6 by 7. Then given equation is, that is, therefore phi of x is equal to 1 by x minus 6 by 7 into x square.